My job for the next few days is to put my wood turning lathe back together. I took it apart about a year ago and it's about time I put it back together. But while I'm putting it back together, I'm going to do a few modifications. I'm going to change the motor on it and give it a speed control, and change the spindle nose to be a metric spindle nose so I can put modern chucks on it. What we need for our 3.5mm pitch thread is, for every single rotation of the chuck, this lead screw needs to pull this carriage along 3.5mm. So I'll come down to this gearbox on the front of the machine and I want to choose 3.5mm pitch. So there's 0.25mm, 0.5mm, 1mm, 2mm, 4, 3, 2.5, but there isn't a 3.5mm pitch. My nearest one is 3mm, so that's C and A. So I'll set these two levers to C and A, and that'll give me a 3mm pitch, which isn't what I want, but I've got a way of working around that. So these are the gears on the end of the lathe. There's a 21 tooth gear at the top, which drives through a big idler and drives onto these gears at the bottom. That one there's a 42 tooth gear that could be used up here but is rarely used. This one here is a 35 tooth gear, and that's the standard one that gives me the correct numbers on this chart. And what it's got on this chart is 3mm, and I need 3.5. So I need to overdrive this gearbox by 7/6 to give me the correct 3.5mm pitch out the other side. Fortunately, this 35 tooth gear is divisible by 7. So if I remove the 35 tooth gear and replace it with a 30 tooth gear, then that will overdrive the gearbox 7/6 of its original standard settings, and that will give me the correct pitch. So the first thing I need to do is machine the inside of this gear to fit on this shaft, because it's the wrong size at the moment. So this is the 30 tooth gear that had the wrong size bore in it. I decided that I'm not going to try cutting an 8 spline like this on the inside of this gear. It would be quite difficult. So what I've done is just machined it out to 7/8 of an inch, which is the top diameter of this spline, and then the gear just sits on top. But it just spins round, you see, so there's no drive. So what I've done is I've drilled 3 holes in the gear and put 3 pins, and those pins locate in the 35 tooth gear, and then I used the spline of the 35 tooth gear as the drive. With a bit of luck it'll go together. There we go. So now I've got the lathe set on the 3mm pitch, and with it running, it's now travelling along at 3.5mm per revolution, which is the pitch I need for the wood turning lathe shaft. I decided to make the mating part first, so I spent this morning making the adapter that goes on the back of the chuck, and that's got the female thread that will go onto the male shaft, and I've done it that way so that I can try this onto the shaft as I go. So the lathe's now cutting the 3.5mm pitch, I've decided to do it by hand, turning the lathe by hand. Now, that's one pass. There's quite a lot of force on this tool cutting this big thread. And I'll show you a little diagram of what I'm doing. So the black bit up here is the metal, and the red bit's the tool. And if I was to push the tool into the work to create the cut, it would be cutting on all this area, all the way around the tool. And that creates a lot of down force on the tool. So to try and minimise that, what I'm doing is I'm pushing the tool in at an angle, at 30-degree angle, and then it's only cutting on this side, and just sort of following along on that side. So what I've got is this figure of 0.5774 to 1. So every 1/1000th of an inch I move in this way, and move about 0.6 of a thou the other direction, and then that follows the 30-degree line down there and reduces the force on the tool. Hopefully this is the final cut. And there we go. Taken to wearing a glove just to turn the chuck, but I'd never ever wear a glove normally when using a lathe. They're an incredibly dangerous thing to do, because you get a loose bit like this on the glove, and a chuck jaw will catch it, and then your arm will get ripped underneath and your arm ripped off. So you're better off just not having gloves on, and then the chuck jaws will just take a lump out your finger and you'll still be alive. So there we are. I'm just going to try the nut on here now. So late last night I finished the thread off on the wood turning lathe spindle. It was too dark for filming, so I'm just doing it now. So I finally cut the M33 by 3.5mm pitch thread, and that now fits the adapters. So that's the adapter for this bigger chuck, so that will fit on there. And then this is the other adapter that I made, and that bolts into the back of my smallest chuck, and that screws on just the same fitment. So now I'm interchangeable with my chucks on the old lathe. First thing I'm going to do today is clean these surfaces up. Anywhere where anything has to mount accurately, I'll clean those up, ready for assembly. I've seen a lot of posts on Facebook where people have got old machines like this and they're wondering how best to clean up these surfaces, and people suggest using sandpaper, blocks of wood and all sorts of things like that. If you use sandpaper, it tends to rub on the edges more than the centre, and it all rounds everything off, and that's not what a machine should be like. And the easiest way to do it is just to apply some WD-40 or thin oil, or maybe diesel or something like that, and just get a Stanley knife blade and just scrape them. There we are. a clean rag, that would look nice. There we go, and it only takes seconds. That's the lathe rebuilt. So I've got a spindle back in now with new bearings. So now it's got its M33 metric nose on there, so I can put my more modern small chucks on. There we go. I've also altered the controls. Originally it just had a switch, just on or off. So now it's got speed control, forwards or stop switch, and an emergency stop switch. This is the variable speed drive that drives my machines. It takes 240 volts single phase power and converts it to 240 volts three phase power. And what I do is, because I've only got one of these inverters and quite a few machines, I plug them in separately. So down here I have a big plug, and currently the wood turning lathe's plugged in, and I've got that one there is my compressor. This one here is this metalworking lathe, and that's how I run each machine. And each machine has got its own control cable as well. This is the control cable from the wood turning lathe. I'll show you inside that in a second. What it does is, when I operate the knobs and buttons on the front of the wood turning lathe, it sends a small signal to the inverter, and then the inverter does the appropriate thing and sends power down the big cable to the motor. I've also got a duplicate set of control switches, and they've got their own 7-pin plug. And what I use that for is for when I've got an electric motor that I want to test. I'll just plug this motor in, and then that'll give me the controls that I need. So I can just unplug the control cable for the wood turning lathe and plug this one in, and I can control the wood turning lathe from here if I want. No reason to do that though. Let's plug the lathe back in. So inside each of the control plugs there's seven cores, 6 of which are being used on the wood turning lathe. So red, white and black are the speed control potentiometer connections. Brown is a 12 volt feed for the other functions. Green is to drive it forwards. Yellow is to drive it in reverse, but yellow is not connected because the wood turning lathe doesn't go in reverse. And blue is the emergency stop signal. And that's what I came up with, because I needed 7 functions, and I was looking for a 7-pin socket, and a trailer socket is just right. You may wonder why I've gone to the efforts of using a variable speed drive on these relatively small motors. The problem I've got is we live completely off grid, and our power comes from solar panels which feed into a battery bank, and then the battery bank feeds into an inverter, and then the inverter produces 240 volts single phase AC, and that's what comes into my workshop here. And if I connected motors directly to the 240 volt AC and switched them on, you get an enormous surge of power as the motor starts up, and the inverter can't cope with that. So using the variable speed drive, you've got an acceleration ramp, a programmable acceleration ramp. So what I've done is I've programmed the ramp in the variable speed drive so that it accelerates slowly. And there we go. And that slow acceleration doesn't overload the inverter in the battery shed. Quick rough snowman.